Well, thank you, Raja, for that great introduction. My name is Anthony, and we'll get started here. First of all, I just want to say that all the work that I'm presenting here tonight is really a collection of a year-long personal exploration into computational design. Before these projects that I show you, I had no understanding of Grasshopper or even Rhino a year ago. So I want to take a different approach from the previous speakers and kind of show that what you can accomplish as a student and being new to Grasshopper. So the first project that I'm going to introduce is familiar to a lot of you probably. It's a project that we did in Computational Design 3 at the end of last year. This project called for multiple stages in Grasshopper and evolutionary processes. They're broken down into three for the sake of the presentation: form generation, mutation, population, and facade development. Each one gives its own complications in areas to develop. So first is the form generation. Since I actually entered the class in the third term, I didn't take the first two. I was a little bit behind in form generation, so I decided to take a relatively modest approach. But my goal was that I wouldn't actually draw any geometry and just let the computational program run its course. So the base geometry that I started with was a simple circle, and through the circle I generated random points and created interpolated curves through 3 points, and then arranged them in scale and rotation to create a lofted surface for my initial tower. The next process was evolutionary solver, and we were basically asked to run an analysis on the tower and evolve its form to improve based on a constraint. So hence the name, I chose radiation as my constraint to analyze the tower. Using Galapagos evolutionary solver that Eric mentioned earlier, we were able to transform the tower in multiple ways. The curves that I showed you in the previous slide were used as a genome, or the part of geometry that was going to be manipulated to generate results, and the goal was to minimize radiation. So on the left, using Darcy-Thompson's evolutionary diagramming, is the initial tower with the original curves generated. And this is a simplified graph of the results that we received, because it took a lot of cross-referencing, because one thing to note is that as these were being developed, there was a close watch on the surface area of each floor to make sure that we were getting the same scaled tower in the optimization. So there was really two areas. There was the needle, which I refer to as the second one, where the top circle was decreasing, or the funnel, which is the other two, where it was increasing. And based on the results, the funnel was most successful because it actually provided shading to the rest of the tower. So here's an image of the radiation analysis from the original tower on top and the optimized one on the bottom. The total decrease in radiation at this point was 12.5%. And these are the new curves that created the loft. As you can see, it's increased in scale quite a bit. The next step was facade development. On the left is the initial tower and its radiation. On the right is the optimized. The facade was created using the paneling tools and operates by selecting the center point and moving it towards a midpoint of a chosen line of the panel, opening to form like a diagonal diamond. So the comparison is at 50% openings and optimized openings. And the result was an additional decrease of radiation by 4.5%. This is just a close-up of the panels and the variations that they created. this one's black. I don't know why any of these are black. Not sure. Okay, well that's all right. I have the video for that project. Well, we can do this one. Okay, well, I think I'm missing a few slides. I don't know what happened, but I'll just go ahead and introduce this. I have a video for it anyways that basically explains everything, but as Roger mentioned, over summer I went to Rome, and it was a course focused on parametric design, but more specifically kinetic architecture, and how we can bring some of these parametric qualities into the real world and adapt physical models and get them to interact with certain constraints. The project that I'm going to show you is for a pavilion design. The main goal was to create a shading system that generated the most shade possible without obstructing views of its surrounding areas, because our specific location, which was Villa Borghese, overlooked the Vatican and the central part of Rome, like the Colosseum. So, I don't know, how can I play this? There we go. So here's an initial study on our facade system, tracing the sun path to maximize shading at all times of the day. This is just one day. As you can see, the panels are rotating following the sun path. This is a physical model, a prototype that is tracing the sun path based on the computer and rotating with Arduino and servos. So the idea is that the Arduino is connected and remapping the data from the sun paths in Grasshopper and sending it to the physical model. This is just another view. So as you can see, the model is actually responding with the computer. Not all the motors were glued down, so we needed hands. And then this is our actual design responding to the sun path. And then there's just a few images of some other models. It's unfortunate, I actually had a diagram or a graph chart that was very powerful, I thought, in our studies, but you can see it on my board outside. After we applied our facade system, we went back and we did an analysis of the comfort levels of our pavilion without it and with it, and it was pretty staggering results. I think it was previously it was about 50% of the time it was meeting comfort levels, and then after it was about 85% of the time. And being that this location was in a very open space in Rome where it gets pretty hot in the summertime, it was very powerful. Anyways, these are some shots of the model. The last project I want to talk about is spinning kinetic facade, which is the model that I have presented outside. There was really no program for this. This was just me coming back, kind of obsessing over Grasshopper and what it can do, and just really going through and trying to develop new ideas. This is the one that I decided to run with after playing around with it for months over summer. So the idea is relatively simple. Using Lunchbox, a plugin for Grasshopper, which is develops panels, facades, came up with a diamond facade system that actually is inspired through paper art. With paper art, like if you cut this geometry in paper and fold and close it, it actually spins if you fold it the right way. So that was kind of my inspiration, and I used that in Grasshopper by dividing the panels and allowing them to rotate on the same axis but in opposite directions of each other. So every other one rotates opposite of the one next to it. Here's just a quick example of open and closed in the early stages of the design before it was really optimizing it to any specific constraint. The thing that I chose to investigate more was a facade that could respond to human interaction, so motion in particular. So this diagram is relatively simple, but it gives you an idea of what the facade system can do and how it can be applied. So as you move along it, it basically traces the motion of a person and responds to it. So the closer you are to a specific panel, the more open it is. I think this can have applications on either sides, being when you're on the exterior of something and you get close to it and open it and you can see in, or when you're even inside a building and you walk up to a window and it opens and you're able to view outward. So this is just a final rendition. But I would just, that's the end of my presentation, but I would just like to, I guess, leave everyone with a thought or an idea. After my investigations and research, I think it may be time to remove static approaches towards architectural systems and instead view it as another living organism capable of responding to specific constraints defined and filtered by its creator. So the creator is the designer, the architect, and I think this is a new developing role for architecture and design. That's it.